Here we're going to look at the applications of quadratic functions notes. And so when we look at a word problem, we're going to be interpreting things in context. Here we have a small rocket is fired into the air. We have initial velocity of 48 feet per second at the edge of a cliff, 64-foot cliff, and it gives us this function. So here's our function for the vertical distance the rocket travels. H is our height, T is our time in seconds. So when asked what is the height of the rocket at T equals 0, we're just plugging in 0 for T. So I can find H of 0, negative 16 times 0 squared plus 48 times 0 plus 64. We end up getting 0 plus 0 plus 64, so it's just 64. But if I interpret that in context, we would say after 0 seconds, the height is 64 feet. Or you could say the rocket started at 64 feet in the air or above the ground. H of 2 means I'm plugging 2 in for T. So same situation, we just are going to need to probably use our calculator to evaluate this. But you do want to show your work through this. So H of 2, if I plug this in, negative 16, you want to put these values in parentheses. So when you plug something in, just put it in parentheses. That will help your calculator understand the order of operations a little bit better. Plus 64, we get out 96. So after 2 seconds, the height of the rocket is 96 feet. Now we want to write this in transformation form. And so when we're looking at transformation form, let's just remind ourselves, what does that mean? That's our vertex form, so it was y equals a x minus h squared plus k. And to do that, we first need our vertex. Our vertex starts out by doing negative b over 2a to get the x coordinate. So if I do negative b, that'd be negative 48 over 2a, so 2 times negative 16. We plug that into our calculator, we should get 1.5. So my vertex has an x coordinate of 1.5, but we need to know what is the y value. So if I find the y value, I'm plugging in 1.5 for x. So negative 16 times 1.5 squared plus 48 times 1.5 plus 64. And let's plug that in as well. So we get 100. And there's our y value of the vertex. Let's just write out that vertex as a coordinate, 1.5, 100. That is our h and k part of the vertex form. So we just want to plug this in, but if we look back at standard form, we find a. So a was negative 16. I'm going to put that in here, negative 16 parentheses x minus h. Well, h is 1.5 parentheses squared, so that thing is being squared, plus k, which is plus 100. That's our vertex form or transformation form. We can use this stuff to help solve a graph if we needed to. In D, we want to know when it's going to hit the ground. Now, if we look at this equation, that's asking what time, when, will the height be 0. So we want to solve for t and have a height of 0. So I'm going to plug in and say 0 equals negative 16 t squared plus 48 t plus 64. We solved a quadratic equation in two different ways. We either factored or we used the quadratic formula. And you can use either method here, but I'm going to use factoring just to show what we can do, because the first rule of factoring is to check for a GCF. And if I'm looking at each term, 48 divided by 16, yes, that works out evenly, so I know 16 can go into 16 and 48. If I do 64 divided by 16, it also comes out evenly. So this is something where I'm going to factor out a negative 16 and be left with a t squared. Then when I divide 48 by negative 16, that gives me a negative 3t. 64 divided by negative 16 is a negative 4. We continue factoring, and we take that trinomial, that quadratic trinomial, and turn it into our two binomials. So t squared came from multiplying t times t. And then our factors of 4, well, we have 2 and 2 or 4 and 1. So 4 and 1 would work to give me a negative 3 if this is a negative 4 and a positive 1. Our zero product property would take each one of those, so I'm just going to move this up here and say t minus 4 equals 0, or t plus 1 equals 0. And we solve it out, that gives me t equals 4 and t equals negative 1. Now when we think about this in context, time as negative 1 seconds does not make sense, but time as 4 seconds would make sense. So we only have one answer that works in context. I would just write this out as a sentence and say, after 4 seconds, the rocket will hit the ground. All right, E wants to know, what is the maximum height the rocket attains? Well, the maximum of a parabola is where that vertex is. So if I look at the vertex that we already found, the y value is our maximum. Our x value tells us when something happens. So I'm just going to rewrite our vertex down here. Our vertex was 1.5, 100. So we have a maximum height of 100 feet. And it will reach this at 1.5 seconds. Will reach this at 1.5 seconds. F says, for what interval is the rocket increasing? And then we're going to find the domain and range. I think it's beneficial to at least kind of sketch out what your graph would look like. So I'm going to make just a general sketch, because what we had was a y-intercept of 0.64. That was the first question. So I know the rocket starts here at 64 feet above the ground, and then it goes up and comes back down. And it makes that parabola. We found the maximum at 1.5, 100. And then we found it hit the ground at 4 seconds. So that general picture is basically what's going on with our rocket. The rocket's not going to do anything after it hits the ground. It's just going to splatter on the ground. But it also didn't do anything before the time started. So this is the whole pathway of our rocket. If we want to know when it was increasing, it's just this little small section here from 0 to 1.5. Remember, we're going to be reporting our x values for an interval of time. So I'm going to say 0, 1.5. But if I put that in a sentence, let's just say from 0 seconds to 1.5 seconds. Now our domain and range will also be in context, since this is a word problem. So for a context of this, we're saying our x values, or our time, has a possible 0 to 4 time frame. So our domain would be bracket 0, comma 4, bracket. Our range is looking at the heights of this, and the lowest possible height is 0, but the highest maximum was 100. So you always want to look at that in context of what's going on. Let's look at one more question. Here we're going to stand at the top of a 300-foot tower and toss a penny with an initial velocity of 8 feet per second. We get this equation to model the height of the penny. So P of t is going to be our penny's height. T is the time after the toss. So what's the height as after the penny was tossed? So t equals 0. Let's find P of 0. So -16 0 squared plus 8 times 0 plus 300. That's just going to end up being 300 if you look at your constant term. So we started at height was 300 feet. And then P of 1. If we're interpreting what that means, this means after 1 second, what happened, or what was the height. So -16 times 1 squared plus 8 times 1 plus 300. We can put that in our calculator as well. -16 times 1 squared plus 8 times 1 plus 300. We get 292. So P of 1, 292. So after 1 second, the penny will have a height of 292 feet. Then we want to write this in transformation form like we already did before. To remind ourselves what that is and just kind of practice, let's write out what is transformation form. So a times x minus h squared plus k. It shows how we moved left and right and then what our vertical stretch or shrink was. So we want to find our vertex. To get that, we do x equals -b over 2a and plug our a and b in. So b is 8, so I'd have -8 over 2 times -16. And you can put that in your calculator as well. You can use your fraction button if you want. But I get 1/4 or 0.25. We want to find out what is the y value associated with that. And 16 times 0.25 squared plus 8 times 0.25 plus 300. Let's plug that in as well. So -16 times 0.25 squared plus 8 times 0.25 plus 300 is 301. So P of 0.25 is 301. That tells us our vertex. So we found a vertex to be 0.25, 301. Makes this equation -16 times x minus 0.25 squared plus 301. So there's our vertex form of the quadratic. And then how long is this penny going to be in the air? How long is a question asking what the t value is going to be? So we want to find the t value, which means the height is 0, and -16 times t squared plus 8t plus 300. If you look at this and try to factor, we want to look to see what's our greatest common factor. So I know 16 cannot go into 8, and it doesn't go into 300. So 16 is not the GCF. We could try 8 because I know 8 goes into 16 and 8. Will 8 go into 300? Not evenly. So we turn out that this one doesn't factor, and we're going to need to do the quadratic formula. So let's just write a little note there that it doesn't factor. So we use the quadratic formula. And then we plug that into our formula. If you don't have this memorized, you're going to need to. So negative b plus or minus the square root b squared minus 4ac is underneath the radical. And the whole fraction is over 2a. So that's our equation. We just want to plug in our values, and we're going to use our standard form. So negative b is going to be negative 8 plus or minus the square root of b squared. So 8 squared minus 4a is negative 16. C is 300. And then all over 2a, so 2 times negative 16. If I put this in my calculator, I'm going to put in what's underneath the radical. So 8 squared minus 4 times negative 16 times 300 gives me this long number, so 19,264. Negative 8 plus or minus the square root, 19,264. All over negative 32. But the problem with this, even if we simplify this down, is we're not going to get a nice number. It's going to give us a radical. And if we're trying to interpret in context, we really need a decimal. So we're going to turn this into a decimal and see what we get. Remember, we should have two answers. So I'm going to do this twice with, let's see, negative 8 plus the square root 19,264. Take that whole thing and then divide by negative 32. I got negative 4.09 if I round. So negative 4.09, and let's find the second answer. So negative 8 minus square root 19,264. That whole thing is divided by negative 32. I get positive 4.59 if I round. 4.59. And now we have to interpret in context again. So if we have time as negative 4.09, that wouldn't make sense. Time can't be negative. So the only time that does make sense is this one. So we would say we'll be in the air, about 4.59 seconds. And then E wants to know what's the highest point. So if I'm looking for the highest point, that's our vertex. And let's remind ourselves what we already found. This vertex is at 0.25301. So the highest point is 301. That's our maximum. So the maximum, actually, that's the next question. So the highest point is at 0.25 seconds. It says when. So that keyword when is telling me I'm actually looking for the t, the time. The highest point is going to be at that value. It will reach 301 feet. So the maximum height is 301 feet. So just be careful and know which question you're actually answering as to, do you want your x value or do you want your y value? The last part here, it is helpful to kind of have a picture. So I'm going to draw a sketch of what we know. So we know it started out at 300. That was our y-intercept. And then it went up and came back down. we have our parabola. We saw it hit a 4.59, and we had a maximum at 0.25301. So our decreasing section, this says for what interval is the penny decreasing, is this interval here on the downward slope. That's from when x is 0.25 all the way to 4.59. So we would say it is decreasing from 0.25 seconds to 4.59 seconds. In interval notation, it would just say 0.25 in parentheses all the way to 4.59 in parentheses, because at that point, 0.25, it's not increasing or decreasing, it's turning. So we wouldn't get a bracket there. The last part is domain and range in interval notation. So our domain is going to be from 0, x is 0, all the way to 4.59. And then the range, our y values, have a lowest value of 0 all the way to the highest of 301. So bracket 0 to 301. Close the bracket there. There are several questions in the lab manual for you to practice on this topic to help you out with applications.